Hello, everyone. Uh, Thanks for coming. Guys from the back, please give me space. Hey, hey, hey. Guys, guys. Uh, Thank you, thank you. Mhm. So, thanks for coming today. We will discuss very important, like probably the most important topic we can discuss is carbon negativity. Um, This is a part of lectures on Siberia. The topics we are discussing are about everything we need to set up a successful and highly efficient autonomous community, autonomous village. And we already discussed the story behind Cyber Valley in Bali. We discussed the energy and water system, and today we switch to the next important building block, which is intersection of the soil, heat, and kind of resulting product of the society carbon produce. Um, Fire can destroy life or create it. And during this lecture, I try to convince you that we have a way to transform waste of our civilization to fertility and energy. So two important properties we actually don't have, like in abundance. They are easily achievable with the technology we will discuss today. I will start from the story of Terra Prieta. Terra Prieta, it was like something like 15 years ago, when some university tried to research Amazonian basin and found where like 30,000 cities of pre-Amazonians, pre-Columbian people. And what we found was fascinating not only from archaeological perspective, but from technological one. They did have very dark, fertile soil, where like the people, local people called terra prieta. This soil, like usually, if you understand how the soils, like what kind of the soils are actually in Amazon basin, it's usually a clay. It's not fertile soil. All fertility in this forest happens on the upper layers. So these upper green layers, they catch the water, and like also fertility happens where the water wash out all elements from this lower layer, and in the end you have like almost zero fertility in these kind of soils. But here was clusters of very dark Chernozem-like soils, which start formation something around 8,000 years ago, and stopped after Columbus came to America. So actually, this civilization that have been demolished. With that, this formation of Terra Prieta stopped. And when people start research this, it turned out it was extremely fertile soil. There was some residues from pods, from bones, like from plants. It was mixed type of stuff. But when scientists analyzed what was the source of fertility, they came to understanding on how biochar works. Please raise your hands who actually heard about biochar before. Something like 10, 10, 10. Okay, no one, almost. Good. So biochar is outstanding technology. This is a chart that actually demonstrate the how after this discovery scientific research start to grow exponentially. So it's like amount of papers that is still growing up to date. And you know, when you see this kind of exponential chart in research, some research field, it's like certainly something there. Before that, I always compare this chart with the blockchain, with early blockchain researchers. We saw it was like obvious that science of this technology starting to take off. It's become progressively more interested because something very fundamental is hidden. When you see the chart like that, try to understand the root cause of this interest for one of the most smart people around. So yeah, after that I named biochar as blockchain for the permaculture, and actually this technology I think is more powerful, and I will try to explain you like how it works. Okay. Science behind biochar is pretty simple. It's a pyrolysis process. Pyrolysis process is a process when you burn the biomass at low temperature, something between 200 and 400 degrees. And the really important property of this process is that you not allow oxygen to go there. Without oxygen, you have you enable this process. First, the volatile compounds vaporize from the matter, from biomass, and after that it become carbonized. So like that carbon molecules, they form a very stable, super reliable carbon rings, which are kind of become stabilized. After that, you must activate it, so you put a lot of like water or steam, and this charcoal become the biochar. So what happens? Actually, a lot of pores open and enable significant increase in amount of surface area in all that porous surfaces. So the process is fascinating because you have several products of this process, yeah, and they are foundational. First, biochar is like later in my lecture I will explain why it's foundational for fertility. When you have biogas and bio-oil, which you can use as well, gas and oil, yeah, if you refine it. And of course you have the output in terms of heat. So basically this like fertility and energy, which are two basic fundamental process of the biochar, of the pyrolysis process. And not everyone understands what is actually the difference between ash, charcoal, and biochar. So it seems like, yeah, I will try to explain. First, ash, yeah. When you burn to ash, what happens? When you burn to ash, everything is just get burned. So all that carbon as energy, it's become vaporized. You have like very slow matter output in this process. And that is the most common process that we usually see in our stoves and like everywhere, and internal, even internal combustion engines, when we have like small particles which are coming out. And I do believe that this burn to ash approach and culture and philosophy is the reason why we actually have this problem with ongoing carbon rise in the atmosphere. So ash is okay. Ash is clear. It's like when you burn, you have some residues in terms of minerals. Yeah, the charcoal is a bit different. Yeah, so the charcoal you usually make when you want to have a fuel. Yeah, so you cook the charcoal for charcoal, and like the purpose, like the difference in the balance of energy which remains in this char. Yeah. In case of charcoal, you optimize for energy output, which will be used later. So if you want to cook on that char, you not like cooking it until the end. Yes, for biochar, you must vaporize everything you can to form this very stable molecules. So basically, like the difference in the temperature and how you cook, how many amount of oxygen you enable during this process, and the outcome in first case, you in case of charcoal, is like you do for burning further, yeah, and biochar you actually cook for supporting life. You efficiently store part of the carbon after burning process. Amount of carbon that you save is significant. It can be 20-30% of the initial biomass. So in conventional process, we never store carbon. In cooking for biochar, we store up to 20-30% of biomass and store it for fertility and life support. The cool stuff around about this is that carbon is super stable thing. It can work in the soil not for 1 year, not for 10. It efficiently work for millennia. And if you learn into how Chernozem, like one of the most fertile soils humanity knows, works, they are farmed million years ago, still they are fertile. So it's a very permanent technology for building fertile soil, and moreover, it's like the only technology that enables fertile soil. How does it work in the soil? How does it work in the soil? So when you put biochar, you put biochar in the soil, it solves several important serves several important functions. First, when water passes through this biochar thing, it's actually capture the elements which water contain. So basically, it's filter. You use activated carbon to suck the stuff, to filter the stuff. So it's become a continuous, ongoing factory for capturing elements. Instead of buying NPK and the other elements, you capture them from a water on a continuous basis. These elements, they are settled down in this like super porous surface. So it's become the architecture and like the storage system for elements. And after that, the biome start to live in there, enabling actually these elements to roots. So it improves actually water retention, nutrient retention. It improves microbial activity, and the result are like you've seen on the picture. So everything can grow 2-3 times faster, like 2-3 times more dense, without actually adding anything extra to the soil. One of the most foundational tasks we're trying to solve while building Cyber Valley is to learn how to build the systems, passive systems, without need for external output. And with biochar actually make it possible. How to produce this magic? Well, the most primitive way is the Kontiki kiln. Okay, it's like the shape of this, like it's a circle that you dig, and can you dig in the soil of custom size. But the big idea behind this Kontiki kiln is like the shape enables this vortex and natural create the zone without access of oxygen. So you build this fire layer by layer, and this biochar get accumulated there. And after you finish the process, you just put there some water to activate it, not activate it, but to make it porous, yeah. And basically it's done. The beauty of technology that it is super affordable. You can do it when you cook your barbecue in the nature. So it's not like super high-tech technology, 5 minutes and you're done. So like it's just the difference on how you prepare with how. So it's not like whether you burn or not. So there are some ways to burn with utility, and there are some ways to burn like actually with harm. So big, yeah. Uh-huh. Mm-hmm. Yes, it's fit perfectly. The cool thing is the shape can be kind of, yes, anyway you have these vortex streams, it must be just round. Yeah, and these vortex streams actually block the oxygen from passing from like upper layer to lower layer. And it makes this, so like once you start this fire, it's like it have some smoke. Yeah, it have some smoke during the first 5, 10, maybe 15 minutes. After that, after gasification starts, you actually like don't have the smoke anymore. I want to show just how it works. Yeah, so it's just burning without smokes. Like some, what I want to say about the smoke. Smoke is the sign that the burning is not complete. So when you see smoke, it means that a lot of compounds, organic compounds, a lot of shit actually like have not been burned. It is go to atmosphere. That is the sign that you do something not good for the atmosphere. Yeah. So the purpose of good combustion is complete combustion, and the sign of it is the smoke. So when you don't have smoke, you have almost pure CO2, which is coming out of the fire. Well, anyway, you have some NOx, you have some like minor compounds, but they are not significant in comparison with the fire which produced the smoke. So this Kentucky kiln is super affordable, super cheap, like beautiful technology and approach for producing biochar to cook the fire in nature, in gardens, in the construction process, like anywhere where you need it. Okay, we have tried this in our case, and it was kind of, for me, it was like eyes-opening thing. Wow, I have this magic miracle. I will cook biochar a lot, and then start to ask the question how much I need, and that's actually the answer shocked me. Yeah, so I start to compute. Okay, I have this 37 hectares of land. I need at least of 30 centimeters to 50 centimeters to fill out. I measure it, I make a soil analysis, and I find out that I have 3% of bioavailable carbon in my soil. And in the Chernozem land, you have something like 12. So the difference, 9%. At this scale, it comes down to 37,000 tons of biochar. Boom. Current market prices are something between 1 to $20 per kilogram, which translates to the amount of money we need to actually make this magic on like my land. Okay, something between $20 million and $200 million. So let's talk the money. Yeah, and yeah, I start to think actually how. Like what we can do with that. Yeah, so I start to think how to scale the process. Yeah, when people say we have different types of capital and soil capital, they actually means that. Yeah, so that is not the thing you can just go and get. If you have this, so like this translate to something like at least moment something like $1 million per hectare. Just like just think about this number. So it's significant investment for any development project. $1 million per hectare at least, at like really cost efficient way to produce it. And $1, I trust me, you will not be able to get biochar for $1. It will be mostly like $3, $5, $7 depending on location. So how to scale it? Make more asada. Something like that. Something like that. Wait a bit. So I tried to research like how to scale it and came to like the state of technology is pretty advanced. So it start to become industrialized, and you have on the market these units that can produce huge chunks of biochar and heat. But the problem of this unit, that the scale of this unit is like pretty enormous. They require some cases like $1 million of upfront investments, and the biggest problem in connection with our autonomous community idea is that the scale of them requires something. I try to count how much a forest I need to sustain this unit. And I came to the number something like 10 square kilometers of productive forest just to load, like to minimally load these units, which is just intractable for our use case, and more like I think for most use cases where you have this cosmolocalism thing, which is we are looking for. Yeah, so you will find quite good designs, but the problem of these designs is that they are more optimized for biochar production, and they are not actually optimized for heat production. Yeah, which is in our case is one of the most important thing, because actually we have problem of heat. Yeah, so we need to find the source of heat, and it's kind of not we are looking only for fertility. We are looking for both heat and fertility. And most things you will find on YouTube and like in the market were small one, no, like quite small. So like in this thing you can produce 1 cubic maybe meter of biochar at one batch, but we are not optimized for heat, and also the burning process mostly are not super efficient, so they are produce pretty much amount of unburned matter. So I came to understanding that actually we need there is no, the solution does not exist, okay? So I tried to find the small stove that is optimized for biochar production, and like, wasn't able to find it. It just doesn't exist. Joy know the story how I tried to build this thing. I tried 10 iterations, 10 times I tried to build it. And after 10 iteration, I find this project. Like the problem I wasn't able like to solve is that complete burning thing. Yeah, so well, thing was working, but I always had this smoke coming. And after finding this batch rocket project, I understand why. Because 10 years ago, one of like the community who actually also into this complete combustion idea, we started to build this kind of stove which burns very efficiently. I came to understanding that actually I didn't have a chance to build the stove which is efficient enough. These guys, they iterate 10,000 times. 10,000, they build some kind of 10,000 stoves to understand exact proportions between the amount of like size of the chamber and the size of the heat riser. So this proportion actually supply just enough amount of oxygen. So it's have this super important property which is complete burn. So I find this, I will show you this table. So it's actually a beautiful one. You see this CO2 thing, and like starting from 6 minutes to like almost end of the batch production, you have zero toxic CO output. Yeah, which is pretty cool. The quality of combustion can be higher when with actually modern internal combustion engines with catalysts. So like I want to give you an idea. So this is the quality of burning actually enable new kind of like burning, because before that project there wasn't actually so efficient burners on like open market. And yeah, but even these guys, they didn't solve this to function task, which is biochar and heat production. So my plan is to iterate on this project and solve this problem. for um, creating open example of the stove, which is possible to build in any village, which is simple to build. This kind of stoves can be built in like $300, $500, depending on the cost of local materials. They work for 50 years. We can steady produce all that goods, continuous stuff. And yeah, I hope subscribe and follow our path to this magic stove, cyber stove thing. So, yeah. Yeah. Yeah, this problem, this stove solve. It was designed specifically for heating. Okay, it have complete burn. That means that it completely burns. Yeah, but I started from very different idea. Yeah, yeah. But how actually you must? What is the difference between pyrolysis? I forget to tell you one important thing. Is, in order to make small scale, or doesn't matter actually, bigger scale pyrolysis stove, you need two chambers. One must heat, so pyrolysis chamber must be somehow heated. Yeah, so in one chamber you must have this complete burn. In another chamber you must control the amount of oxygen and like kind of different task, which is vice versa. You must not burn, you must heat and do not allow oxygen. So in one chamber you have a lot of oxygen and high temperature. In one chamber you have low temperature and no oxygen. And that's how a perfect stove must work. And I was, so actually I'm showing you this because I was able to find the solution from open source people for the part of the problem. Understanding how to build a like really efficient stove is very hard. It turns out it was very hard. So, couple of words about carbon negativity. I believe that biochar is the only technology to slow down this trend. The only, I will repeat, the only technology. All the technologies, carbon capturing technologies, like actually they are making things worse. While you produce the equipment for capturing carbon, you produce more carbon. You have a natural process which is like forestation. You put more trees and it seems like it's work, yeah? But the problem with reforestation is it's super slow process. Yeah, biochar, what it allows to make this circle faster. So what happens when you like how does this carbon accumulates in the soil? So the forest is growing. When it's decaying to carbon, like layer by layer, and you have in the end this like the amount of carbon grows in the soil. And what you do with biochar is just you make it, the process not happens in million years. It can happen in several years. So you can significantly amplify and make it faster, the process of carbon, natural carbon sequestration. And because it's very useful, yeah, because it's very useful and very affordable, I bet that is the only technology to start this slowdown of carbon accumulation in the atmosphere. One more reason why it is the only process, it's the only known process with positive feedback loop. What does it mean, positive feedback loop? The more you put biochar, the more biomass you have, the more biochar you can produce. So actually, people who embed the process of biochar production in his growing culture, start to see this huge accumulation of fertility from like third, 5, 7 years of operations, because I will repeat, the more you put biochar until something like 12%, which can take years, the more you put biochar in the soil, the faster the biomass appears, the more you can produce biochar. The only known process with positive feedback loop is biochar, and that's why I do believe that is foundational for civilization. I will promote the idea that is the technology we as civilization missed on some stage of development. I ask my friends to draw this civilization like H3, you know, and embed the biochar there. And here is from ChatGPT. So it's like demonstrate that in a digital era, when you have ecology technology, you just have this open it, you know, simple stuff like kilns, which are dependent on the biochar technology. We obviously miss this, and that is the reason why we have problem with carbon in the atmosphere. And this is from Grok. He put this into the center of all that soil and environmental sciences, and they give interesting idea of biochar fusion. So I try to just, yeah, to have some fun. Yeah, so this is the future of biochar fusion, when we just will cook it from, almost the atomic, like it's like atomic fusion, but biochar fusion. Yeah. Okay. I start to think like what I can really contribute to this idea. So you see, the technology is here. It's as old as the universe itself. It's provenly working with some, trade-offs. You must understand how to apply biochar to your soil to make it fertile. It's not the topic of this discussion, but the technology is here. Technology is super simple. It's super cheap. It's cool. So the only problem is like how we could change the culture, like mindset of people. Like farmers start to use it, embed it in their processes. People who have gardens also start to use how we can actually make it popular. Okay, and I came to the idea of founding Burn.City. It's the event that will happen every year in Bali. It will be alternative to Burning Man. Yeah, so this idea of Burning Man is actually the culture that was created by boomers, who actually the reason why we have the problems right now. And they burn to ashes. And burning to ashes is like, spending everything you earn without reinvestment. Biochar technology is about reinvesting for future generations. And the only way to fix this, I believe, is to establishing this kind of the movement with symbol that will reflect the idea of reinvesting for future generations to the soil, to the future. So I invite everyone to set up this tradition in the end of February, beginning of March. So this festival will be very close, like actually the same in the same dates when Niepi is the Silence Day in Bali happens. So come to us to set up this tradition and help balance out the atmosphere with carbon. Thank you. Yeah, so for those who are not still in our Telegram group, this QR code. Yes, subscribe, like, bell, like. Yeah, and I have personal Twitter, XCOM, and if you want to follow my research, which is not only around autonomous villages, but also related to cutting edge stuff like cryptography, game theory, tokenomics of and blockchain engineering. Yeah, this is my XCOM account. Thank you. Questions?
As I know, your project now in Bali, and in Bali, if you put a stick into the ground, it grows. Why you need biochar there? Like, is it grows even faster with biochar?
It's not entirely correct, so it depends on what stick you put. Yeah, it's for example, avocado stick is really in our case is growing. So there is a story when we build these stairs, from the stuff we have. Yeah, and builders we just build it from like what we have, and like took and some of the sticks was avocado and they grew up.
So your ladder start to grow.
Yeah, but the reason is not only about the speed of the growth, but about fertility. So you can have very fast growing tree which doesn't produce actually anything. That is the first reason. Second, I can tell you the story about bananas in our region. I learned from locals that actually this region we are based 15 years ago was the biggest producer of banana on the whole island. So we produce something like 60 tons per hectare. 60 tons per hectare of banana, which is enormous amount of banana. And when something happens, that actually bananas start to got sick and stop produced. So like the clump was growing and die out. Yeah, we created different theories. After research, I find out that actually the reason why they did have these is that from the south the water coming very acidic with rains that reduce acidity, dissolve alumina in the soil, and that remove immunity from banana from different fungus and other stuff. And so like the productive so how carbon can fix that, it like help to regulate the pH and increase immunity for diseases because it's make nutrients more bioavailable. So this bioavailability thing is the most important. You can have a lot of nutrients in the soil. If you don't have microbiome in the soil, plants cannot almost not like all the plants cannot take chemicals directly. It's very hard for them to do. Where have all that symbiotic relations with different kind of bacteria, protozoa, etc. So it's like the soil is living organism. So yeah, it's a matter on efficiency. If you can do it like faster, more efficient, why not to do that?
Okay, and second question connected to efficiency. If a farmer builds such a stove, let's think like a medium-sized house, maybe like this. Like this. For how many square meters or hectares of soil fertilization it will be enough?
I like the idea. I actually try to translate here is that biochar it will never be enough.
The more the better.
Yeah, the more the better. You just embed it into the culture,
okay, but
and you do it on like regular basis, just increasing your fertility, increasing. You saw that people from Amazonia, they collected this thing for almost 10,000 years, and how much you see in the end? 2 meters of dark soil. So how much, actually you need? The more the better.
The question is, will it be even visible, even noticeable, if somebody put the effort, build such a stove, and every day have fireplace in house, and
of course, we try to compare how taro can grow. It was in our case, it was just 2-3 times faster. So like this kind of taro in normal condition grew up in 9 months in our case.
The question is in amount, like one stove like this in 1 month can produce certain amount of biochar. I guess you can estimate plus minus maybe 30% how much. And this amount will be
visible. It
To
will
see-
be
to s-
visible.
Ho-
It will.
for how many square meters or kilometers?
Well, it depends on the density. So you usually come like this. Like let's imagine the 15 centimeters heat riser stove. So that actually I did show. Yeah. This kind of stuff. Yeah. This.
Yeah.
This. So the batch there is something like 6 kilogram of wood, which can result in something like 2 kilograms of biochar produced. Okay,
Mhm.
just like raw
Oh,
estimation.
yeah.
2 kilogram of biochar produced you can put on several square meters. Yes, and in 1 month you can fill out 100 square meters of your bed, and 100 square meters of a bed 1 hour can feed actually already like can supply part of your ratio, like food ratio. So it's significant.
So
It's
in
just
1 month
get.
already see the result. Like
Yeah, you will
my
see.
pomodoro
Yes, on
grow
that small
faster.
scale. At small scale, you will see results if you cook it properly. Because I didn't actually mention here that you need an inoculation process. So it's come empty if you not put nutrients into this biochar thing. It will first 1, 2, 3 years just suck from the soil, so it get things worse. Yeah. So like you must cook some compost. You must find a way to put nutrients there to prepare it for like to charge it. Yeah. So charging it is like the standalone process. I didn't mention that, but if you charge it and put it, it will you will see results in like you will start to see results. No questions anymore. Thank you, friends, for coming and discussing this super important topic of reinvesting carbon. I forget. Come tomorrow for discussing how we actually how to create gardens. Yeah, I think it's also very interesting topic. Yeah, and we will share some ideas and also discuss practical solutions to this.